Do I have any others of these pages? Going once? Yeah, that's it. That's really great. Have any others? Marcos, sit down. Asia, put them away.
What is this?
It's Yu-Gi-Oh! It's my Yu-Gi-Oh!
What?
Asia.
She's recording.
Thank you.
Right. Oh wait, I need to spell it for you.
Cool. It's fine. I put your name on it. Guys, get out your binder, reminders. Write down tonight's homework assignment.
We're going outside to Sunspots?
Yeah, that's the plan. Asia, sit down. Get what? Why? What'd you leave it up there for? Where is it? I'll send Jamie for it. Where?
Oh, it's funny in that video. He's all sitting in there with his wings on. So.
Come on! Jamie will get it for us. You need to sit down. Her binder reminder.
You know how to make a cloud, Victor? Victor.
And lunch.
I can beat your bike on a little with a big umpire. Please, let him rest.
That's what I'm getting.
Okay, I'll beat you. Slow X on 100 or whatever you have.
Yes.
That's alright.
And Mario has
No. What did I do? Oh.
You late?
Not late.
You can write down tonight's homework assignment. It says read pages 145 to 149. On page 149, I'd like you to do questions 1 through 4, please. Questions 1 through 4, number 18. And as always, write out the questions and the answers. What you need, Marcos? Cool. Carla, could you go sit in your actual seat? Thank you. Yes, Asia. Oh, I hate when you guys do that. As soon as you've got that written down, we need our little Sunspot data sheets, but I can't remember whether we had some for today or whether we need to make some.
We need to make some.
Okay, then I'm going to pass out a piece of paper to you, tear it in half like we've done before, take about 1 inch off the bottom, and I'll pass out compasses so that we can get the sun's shape drawn before we head outside. I think I left enough for Mark, so. Carla, can you wash that off your hand, please? There's a sink right behind you. Did you go find Asia's stuff yet? Okay, take a roll. That's cool. Okay, I thought I gave you one, but.
Girl.
There's one. Pass that one back for Mark, would you?
Are you gonna watch this tape after?
Nope. I'll have yeah. Why, are you planning on doing some rude symbol when my back is turned? Is that it?
No, because like if we do something and nobody comes in, like
I see. No, I will never see it. Take 2, pass it back, and there's 1 extra for Mark. So, Carla, once it's washed off, you can sit down. Let's see, there's some next to the sink over there. Take 2 and pass the rest back. Set the compass at 4.5 centimeters, please. Asia, put that away, or I'm going to read it out loud to everybody on tape. Thank you.
That'll be the funniest.
And we can catch her reaction on tape too. That'd be really great.
Marcos, it's just a compass.
Separate them in 2 halves. Take about an inch off the bottom, please. Draw your sun circle about in the center. Fold in half. Turn. Yeah, that's it. That's it. No, he went to the nurse's office. He wasn't feeling well. Yeah. You can actually draw a line through Joe's name on there. And was that it for this class that transferred to the high school? Is it just Joe? I think it was just Joe, actually. So that would be fine. Which one is number 1, Jamie? Which one of those is number 1?
What to put it on? How many centimeters?
4.5 centimeters.
Let's make a clock.
It's hard. Can we do the other circle with data paper too?
Yeah, please do both circles because I don't want to have to do this again tomorrow. I just like to be able to go out and get the sunspots real quick.
Write it down now.
You know what? Every single day I would like you to act like perfect kids. If today is the best you can do for being perfect, I'll take it. That would be great. Thank you. Camera 1, camera 2, yes.
What camera?
This camera?
Fade to Asia. There we go. Okay, let's get them separated. Get the covers off. And find a space in the sun. Asia.
What time is it?
And it'll probably be about 1:30 or 12:30 when we have them set up out there. Okay, put circles on both data pieces today and tomorrow. Put sunspots at the top, name, date, and the period, and the time of 12:30, which is about when we'll be out there. Yes.
Shall we go out there when we're done this year?
Well, we're all heading out there. Hey, tops off. Let's get the stands from the telescopes and head on out. Okay, gather your stuff. Okay, seriously, that's probably why you don't feel well, Rodney. He's got a temperature of 102. So that's probably why he doesn't feel well. Let's go, folks. Bring them outside. Find a spot in the sun.
No, I took out your brother. You got your brother. Where's Kyle at?
Where did you see that? I never told him that, or told her that you liked him. I never said that she liked John.
Mark your sunspots and track 1 moving west, please. Come on, you guys. Everybody else is out. Let's go.
Just make it fast.
Please be careful with them. Come on, Marcos. Okay, any of these areas in the full sun is fine as long as you're not behind tree shadows. That would be fine. That's fine. Needs, Melissa? It needs a little adjustment this way to get it more centered.
Are you my group? You're in the right
Oh, in the camera correct side.
I'm not working very well.
You're getting it. Did you make the shadow disappear on the gnomon first?
My face is what it is. I cannot copy.
There should be no shadow up there. So can you tilt it left and right so that the shadow goes away?
No, you're not. You're not. No. You're supposed to be able to move it around.
And now you got shadow on this side.
Those, some little
We're almost
dots.
there. Now you just need to tilt it a little bit to make. Now you should be able to see spots here. If you line those up in the center of the target, you should have your sun. There it is, right there.
I call the sunspot.
This shit moves so
A few
fast.
small adjustments.
I didn't do my work, you know.
And you all set?
The hell, I can't.
Please mark your sunspots and track one of them moving west. Yeah. Sure. There's a sink right over there. I mean, a faucet right over there.
Is this sunspot the big one?
I don't think so. Talking about this thing right there? I think that's just stuff on your mirror or your lens.
Mark the other ones over there.
It's the small black specks you're looking for.
It's the group.
Man, it's second.
Where's Rodney?
Okay. Did we get them tracked west? Did we?
Get out of the way.
Okay. So you guys haven't done yours yet? Okay, well you're really close. See these white spots here? Yeah, all they need is in the center of the target. See? That's it. So there you go. Then you need to mark them. Where's yours? Okay, are we gonna mark our sunspots and track them west? You need to track one of them moving west, like we learned how to do on Monday. Just wait. We'll all go back in about a minute or so.
Wait, we gotta find out what
Asia? Asia, what are you doing going into other people's classroom? You're standing there with the door wide open. What are you doing?
Oh my god.
Let's stay away. Ladies?
I'm done.
All right, that's great. Did you find, you didn't get one moving west?
Hairspray.
No, you didn't.
What's west?
The direction that the sunspots move. When you put it on there, you're supposed to let the sun move and make a mark for one of your sunspots as it moves.
What's this one?
Then how come there's not a series of marks? Okay, you got to mark them, and that way we'll show you the direction of west. Hey folks, you got to mark not only your sunspots, you also have to track them moving west so you know which way your image is oriented. So please track one of your sunspots moving west. Well, that's what you got to figure out on the where the sunspots are moving is west. Okay, well then that would be west. That would be fine.
There's one right there.
Are you guys about finished, or are you just goofing off?
That little thing looks like dirt.
It's not.
Like a little tiny piece of dirt. Already marked them all.
They just copied it all off of you instead of actually doing it? That's so helpful.
That sounds like it.
Okay, folks, let's get your telescopes and bring them back in.
You guys get the other half,
Put them together, get the covers on, bring them back up to my desk.
Asia, what?
Mark, Raymond, come on, you guys. Emma, who's sitting out there still? Come on, Ivan.
Come on, Yvonne. Come on. Come on,
That's enough, Marcus.
Yeah, it's all over.
Get them back together, cases on, bring them up front. Jamie, would you collect all the compasses? Please send the compasses to the front of the room so Jamie can pick those up.
Don't just throw it, Keisha.
Mom, you the one
I'll take it.
My name is Jeffrey.
Jeffrey Vincent.
I can't see you framing.
Jeffrey Timothy Vincent. Timothy Vincent. Jeffrey Timothy Vincent. Oh, wait. What's your name?
Last year, yep. Yep. She was in my algebra class. We gave stuff away in there, huh, Myra? Last year's algebra class. Just like gave you stuff, remember? Yeah. She's looking at you in the picture. Like candy bars and sodas, remember? Yeah. I need you guys to take out the lab sheet that we went over yesterday, please.
I need one.
I remember somebody paid like $3,000 for a cup of soup or something like that. Remember in the secret bags? Remember the ones we rolled up and stapled shut? That was funny.
I need one.
They're on the counter up here. Folks, get at your labs. Find your spots, please. Cece, watch your mouth, please.
Sorry.
Was I there?
Mark, find your seat.
I'll talk about
You tell me the teacher
I mean,
They go in the bag on the desk. You can do that for me, please.
always in my face.
Okay, folks, I need your attention up here, please.
Oh my god. My mom told me
Good to pack it quietly. You mom.
Okay, everyone should have the Pulley potpourri sheet out in front of you, the lab sheet. I do. It's my lab. We're going to get started on the lab today. Folks, I need your attention up here, please. I'm glad you guys are having so much fun coloring inside the letters. If I could get your attention up here, I would really appreciate it. We went over this yesterday. I'm just going to recap it today because it's been 24 hours and I know you forgot. You're just gathering 3 pieces of data from each pulley setup. You're gathering the effort distance, the effort force, and the resistance force. As I went over yesterday, you measure the resistance force just by picking the weight up with the scale. And you measure the effort distance by using the ruler in centimeters to measure how far you pull the string when you lift the weight by 10 centimeters. The resistance distance in every case is 10 centimeters. If I can have your attention back here. Just quickly go over this for the first setup again. There are 2 rulers back at the station. You'll be using both of them at the same time. One person is going to be measuring resistance distance. One person is going to be measuring effort distance. So you have one person using the centimeter side of the ruler. There's an inches side. Don't use the inches. Use the centimeters. They're going to be measuring how high the bottom of the weight goes up. When it's at 10 centimeters, that's as far as you're going. While they're doing that, the person applying the effort to this simple machine, the person pulling on the string, is going to be measuring how far they have moved the string to raise the weight 10 centimeters. Now, some people in earlier classes were just writing down the numbers on here. They would just be holding here and going, oh, that's 55. That's not how it works. It's how far it moves. So when the person is reading the resistance and they say, oh, that's 10 centimeters on this thing, then you'll stop. Where did you start? Where did you end? If you started at 55 and went to 60, or went to 45, depending on how you turned, how far would that be? So you started at 55 and you pulled the string down to 60 on the ruler. How far would that be? Be 5 centimeters. Say you started at 55 and it went to 45. How far would that be? 10 centimeters. So it's how far you exert the force. Asia? It's the distance over which you apply the effort. That's what effort distance is. So if you start here and extend it that far, that's the effort distance. A couple things to be aware of when you're doing your measurements. If you pull it at an angle, your measurements won't be very accurate. So you want to make sure that you're pulling straight down in the direction that you are measuring. Secondly, you want to make sure that when you're measuring the force, you're also pulling straight down. Straight down really helps on this lab. All right, so that's effort distance, probably one of the harder things to measure in the lab. We went over resistance distance. What is it for every experiment that we're doing? That's force, as in newtons. But what's the resistance distance? Look on your lab. It's already filled out. It's 10 centimeters. So 10 centimeters is how far we're lifting the weight up. How far we pull this to lift the weight 10 centimeters is our effort distance. The forces, I went over those yesterday. Got to zero these things. The resistance force is just how much the resistance weighs. And as you guys just said a second ago, we're measuring it in what? We're measuring it in newtons. Estimate to the closest quarter newton. For effort distance, again, I showed you that yesterday. You need to tie a loop in the string. You need to zero it out upside down. And you're going to pull, and it works, again, much better if you pull upside down. If you pull upside down, I'm sorry, not pull upside down, pull straight down. If you pull straight down, you'll get much more accurate measurements. If you do it off to the side, it's not going to be as accurate. And again, estimate to the closest quarter. Those are the only 3 things you're doing for each pulley setup. There's 4 pulley setups. You're not going to get them all done today. You might not even get the first one done today. That's okay. Better that you get accurate data than that you just rush through all of these. We got time. We're going to spend a number of days on this. Mechanical advantage, lastly, when we've got all your data, we're going to go back and do mechanical advantage. But you have to have good data. So don't worry about mechanical advantage yet. All right, at this time I'm going to divide you up into 10 groups and send you to a station. Get started on, well, you can do any of the pulley setups you want. It doesn't matter whether you start with the first one or not. But let me sort of divide you guys up here. That'll actually work out just it's fine. Carla, I'm going to go ahead and put you and Mark with Marcos, and you guys will be at the first station over there. Don't kill each other. Debbie, you guys are going to be here on the other side of this first station. Karina, you guys will be on this side of the first station. Cece, you guys will be across from Mark's group. Asia, you guys will be at this third station over here. Raymond, yes. You guys will be just across from that. Sarah and Elizabeth, you guys will be where Carla is, working at that station. And Jeff and Myra, you'll be just across from that. And let's see, Alex and Zach, you guys will be at this station back here. And you guys will be at the very last station on the end. Okay, let's head to our stations, take your data table, let's get them set up and get to work. I think those were worth 50. But is there anything over 50? I think it was just 50. So go ahead and put 50 on there. If there are knots in your string, other than the one at the end, you're going to want to get those out. They don't go over the pulley well. Yep. You guys are sort of working at different ends here, okay? You probably want to put the loop through. It doesn't really matter. But the loop hooks onto the weight. It's just you have to pull a lot more string through if you put the bare end of string through first.
You can't just go like this and then...
Sure, you can. That's fine.
No, it's go like gently. Where's the weight? This loops around it?
This hook's through.
That's really cool.
Gotta keep the string on the pulley though. Yes?
Not even gonna land on the ground. How are you gonna start at the end?
I have no idea what you're talking about. You tie a loop in the string and pull down when you're lifting the weight up and see what reading you get. How'd you get effort distance on there, Zach? You need the difference. So, what's the difference between 57 and 41? She has to measure how far hers went while you're measuring that.
You guys aware?
Sarah, you're measuring how far your hand moved while she lifted that. You want to start with it on the ground. Start at something even. And when she says, oh, that's 10 centimeters, then you look at how far you went. Okay? So you start, it's how far the effort string is. Yeah, that's effort distance. Yes?
What is it if it's from 50 to the one right here? Do we count 1, 2, 3, or these little ones?
Well, the little ones are what? The big ones are centimeters, whatever the little ones.
Millimeter?
Either millimeters or tenths of a centimeter. So it would be point something. Trying to measure it accurately, yeah. To the tenth would be fine.
I'm confused.
Which one?
Alright, put your hand up.
I don't either. What am I supposed to do? Just pull it up and be like, woo, look how far I went.
Yeah, that's it.
No,
You're
seriously.
supposed to actually measure some stuff along the way, and what would that be?
Then what do we do after that?
Dude, just leave it like this.
What's up?
Hold it.
All we do is pull it up, that's it.
Okay. Well, we need to let it go.
Hold it.
How far are you supposed to lift it?
Hey, girl.
10 centimeters.
Okay. So when that's being lifted 10 centimeters, you want to know how far you had to pull this down, which means you need to
Where do you start from?
to measure. You can start from anywhere you want because it matters where you go to. So I'd start at something even,
60.
but it has to be straight down, and you have to know where you started. Asia, it's going to fall.
Start at 60.
Alright,
Okay, look.
hold it from up here.
But you got to hold it somewhere so that you can pull.
Okay. Ready?
Oh, God.
You got to measure it while you do it, Asia.
You do it.
Yes.
How do we do this?
So first grade working with the block.
Don't worry about that yet. We're going to do that together once we got our data. Asia, just measure while you pull down.
I don't understand it.
Come here.
This is
Asia, let's say you started there,
okay.
and by the time that thing was 10 centimeters off the ground, you were here. How far did it move?
Told you.
How far did it
I
move?
understand it.
I started at 50, I went down to 44. How far did it move? Or you can do it this way if you like that better.
It's the same one.
Started at 50 and I went to 64. How far did it go?
10.
50 to 64 is 10. Okay, so it would have been 14 centimeters, right? That's all you're doing. But you're
Then where do you write it down?
under effort distance. But guys, I wasn't doing it for you. It was just an example of how to read it. Okay? Can't write down 14. When this is 10 centimeters off the ground, you want to know how far this string was pulled to lift this 10 centimeters off the ground. That's what you're measuring.
Ow.
Then go back to your spot.
We need to show you.
Aren't you on the other side measuring?
Oh, I thought you were.
Get this.
Tie a knot in the string, pull it with the scale, read the reading in newtons.
Okay.
So,
I didn't think Stephen.
oh yeah, pass everything back. That's cool. Thanks. What's up? It's been in there for a while. I've already seen it. So yeah.
Right here?
Yes, ma'am.
Like on this, okay, because we were doing this on this, we hooked it up to here.
No.
I was listening to you, but I kind of, we did that.
You need 3 pieces of data. Weigh this thing, that's resistance force. Tie a loop here, pull it down with the scale, that's effort force. Lastly, lift this 10 centimeters off the ground by pulling here and measure how far you pulled this to lift this 10 centimeters off the ground. This is the effort into my string, so how far I pulled it is going to be what?
10 centimeters.
Well, that's what you're going to find out. But you're going to find out for most of the pulley setups, it's not the same. Okay? No, yeah, for the force, yeah.
So where do we weigh it?
Yeah. Okay, which part are you guys stuck on here?
We don't get the whole thing because I know resistant force.
Okay, that's where you just pick up the weight. It's not pounds. What is it measured in? Newtons.
Measure it. Do the same thing there. Where's the thing?
It's not 4.5.
What are we measuring though?
Halfway between 4 and 6. That's not 4.5.
Oh, what are we measuring though on this?
I just
You're measuring 3 things. Victor just did one of them. Okay, you're
Well, what is
sure you have it zeroed before you started? I'd ask the same question to Victor too. When it's not hooked up, is it at 0? No, it's not. So you want to adjust it so that it is in fact on 0 when you start. So that's resistance force. Effort force, when the weight is on here,
5 newtons.
tie a loop, pull it down, read what the force is on the scale.
I don't get what you're saying. Set it to 0. Like I can't look.
This thing goes up and down. Put it so it's on 0. Yeah.
Okay.
It needs tied up here. You need a pulley here, weight here. There's a loop of string up here that connects your pulley to your weight. The string from the bar goes through the pulley and up, just like it looks in the picture. No, but I have paper towels over by Debbie there. So I think the tissue box is all empty.
Okay, what do we do with this?
That's what you measure the forces with.
So it's this one and that
You can use it to measure resistance force and effort force.
We got 4.5.
When I did that, I started at 50 and I ended up at 64.
Okay, so that would be how many centimeters? 10 centimeters. Yeah.
So where did I write that one? Effort distance?
Effort distance, yes.
weight.
4 newtons.
We put that on.
Now, did you have it zeroed before you weighed it?
Yeah.
Okay, it should be at 0, and you'll see that it's way above the 0.
Oh.
Actually, just slide this up and down to get it on 0. You're going to want to get the knots out of that when you're done, too.
Shed white all over me. It's not 4.5 newtons. Look, it's almost 6.
It's 4.5.
It's almost 6. Look.
You have to make sure it doesn't move.
Watch. Isn't it almost 6?
5.
Probably way.
Yeah. You want to take this off. Don't worry about that until later. We're going to do that all together. I'm going to take this off of here because... Yeah, you need the knot out of that too. You need this off the weight. Instead of being looped around here, you need it looped around up here because it's supported from the top.
How do we find the effort?
When your weight is on there, you need a loop here. Put the weight off the ground, hook the scale up so that you can read on the scale. Okay. Asia, what you working on? Asia, what you working on? Did you help Ivan out with the lab setup? Yes.
Force, distance, and force. And effort force.
Okay, effort force.
Average.
Effort force. Don't worry about mechanical advantage yet. Effort force. You need to tie a loop here in your string. You need to lift it off the ground.
You said not to tie anything.
No, I didn't. I said make sure the knots are gone when you're done. I specifically told you to tie a knot here because you're going to hook this up to it and lift it off the ground and read the effort force. That's effort force. The effort distance is how far this moved in lifting this 10 centimeters off the ground. So you're going to have one person measuring that it's 10 centimeters, the other person measuring how far their fingers moved, and they did that. Thanks.
But Miss Ingalls sent him in.
Miss who?
Miss Ingalls sent him in.
Oh, it's from Miss Ingalls. Okay. So I got 2 of them. Just Alex. You got stuff to work on, dude? Okay, come here. Thanks. You can work right there. That'd be fun.
Hopefully I never have to use this.
Yes, Zeppelin subs are here. What's that? I have no idea why that's on there. What is that on there?
Yeah,
Is that the day you couldn't find a blank piece of paper and I stamped that on there for you?
Because there's no more. Okay, look it. Let's do this. Okay, I'm gonna bring it out.
I don't remember stamping it either.
Off anything.
I have no idea what that is. Yeah. Alex, you need to sit down. You just sit down.
Wait, it's not that. That's 10 inches.
You guys are
centimeters.
seriously going to want to get that knot out of there. It really messes up the pulley.
10 centimeters.
No, I said you need to tie a loop to measure effort force, but you don't want any knots in the string. It messes up going through the pulley.
You have to have your finger right here. Like a.
I mean, it look like this, man.
What's that?
Betty, like this. Betty. What are we doing?
I don't understand what you're saying. The only time you need a loop in there is when you're measuring the effort force. Other than that, the knots should be out of the string.
Put it down?
Yes. That's fine. It has to be enough so that you can, well, it should be on the pulley for one.
Stephanie Lopez.
And then you have to pull down to make the weight go up. No. You want to pull down with the scale so you're actually measuring the force on the...
So like this. Oh, sorry. You do it. I don't understand.
There, that's it. Now pull down. On the scale.
The scale.
On the scale. Let go of the other string. There you go. That's it.
But then you would be looking at it.
Yes, you're going to be looking at it upside down.
It's like 4.5. I get it.
There you go. Yay. Now untie it when you're done.
4.5.
Yes, but you want to do it straight down because if you do it at an angle, it gives you a slightly different read.
Here, right?
Where do you tie that from?
You need to tie your string at the top, attach your weight directly to the pulley with this little loop of string that I put up here. And then you need to run your string through the pulley and up, and you'll be lifting in an upward direction for that one. Yes, ma'am. I said yes, ma'am.
Oh, I see. 20? No, wait. No. No, not that.
Yes,
We
ma'am.
already finished that one. The other one. Where do we put it?
What's 38 centimeters? No. It's not. It's how far you moved it. It's how far you moved it in raising up 10 centimeters. So start somewhere even, like 50. Mario, measure the weight. Measure the weight. And tell me when it's 10 centimeters off the ground.
How do you tie a knot?
Right there?
Here, just
Okay,
use
I'm at
ours.
60 now. Where did I start? Start at 50. So how far did I pull it?
10 seconds.
There you go. That's what goes in this first spot. The distance that you moved the effort string. The effort distance, yes.
We already did this. How do we do this?
You're going to tie your string to the top. Actually, you can just loop it through around. It's going to go down through the pulley. The pulley will be attached with this little loop directly to your weight.
Whoa! I don't get it.
No, I look at the picture. I want you to look at the picture and set it up like the picture. You finished all 4 of them? Or you finished the first and the second? Can I see your data? Is it the last one, Zach? You guys were able to get the first and second ones done? Oh, it's you guys.
What'd you do? Look at this.
The effort force was 16 newtons. Okay, that would be effort distance. Okay. Did the resistance force, how did the weight get? Your weight was 3 newtons both times? Which weight do you guys have? Oh, you guys have the brown one, right? Okay, so that one's different. Okay, the one thing you didn't do then on either of these setups is correctly figure out the effort force. That's the one where you tie a knot in the string, hook the scale up to it, and pull. No, you didn't. And does that say 16 also? Okay, that one's not right either. When you lift this off the ground by 10 centimeters. Marcos, stop it. When you lift it off the ground by 10 centimeters, how far did this string move? That's what you need to measure. Okay? I don't think you did it right either place.
This is hard. We need Wesley here. He's a smart boy. You took my stool.
When you get it set up again, call me over. I'll show you. Yeah.
Can you help us with part 2?
Yeah.
Okay, what you stuck on?
Why is it over this?
Okay, well look at it. Your string should be tied to the top bar. Do you see that in the picture? Well, you can loop it through just like you. Here. I'll give you one hint. Hand me the other end.
Woohoo! You're sitting on the couch.
I'm just telling Mark.
Then you hook the pulley directly up to the weight like it shows. Run the string through the pulley. That little loop of string, yeah, that's how you do that part. Ivan, you gonna do anything today?
Okay, now let's tie it up.
I did practically everything.
Cool, thank you. Did I actually look at it where I can see it?
How do you do mechanical advantage?
We're gonna do that one together. What was 25?
That's what I told her.
Where's the say 25?
23 or whatever that says. What is that?
That says 23.
So where'd that come from? Did you
Take
just
12,
make that up?
6. Oh wait, I forgot to add 10. Huh? Okay, it's 33.
Why?
Because I added it all up.
Why?
Why not?
Alright, so for this one, we have to do.
Why?
I don't know.
It doesn't make any sense.
Well, I don't know how else to do it. That's why.
How do you do this part? Where you put that?
You broke it.
That's your effort force. You just pull that one down. Yep. Hey, that's it. Perfect. Excellent job. Okay, folks, it's time to clean up. You get out of here when your stations look exactly like they did when you came to the station. So everything hung back neatly where it belongs.
I was already like that.
After school.
Next time we can pick up our notebook.
You're scaring me, Rihanna. You did? Seriously? I have no way of getting it out. Goes down about 6 inches before. How about if I read the whole thing between now and 6 in the end of 6th grade? And it's just in the drawer. You come after school, you have it. Yes. That looks perfect. Yes. Tie a knot in the string, hook the scale through it, and pull. Read what you get on the scale.
I don't think it's down there anymore.
That's the force that gravity is pulling downward with. That's correct. That's the resistance force. No, don't worry about that yet. We're going to do that together. Exactly. It's just a different pulley setup, but the calculations are the same. I thought I told you guys that yesterday.
You said Friday.
Right, tomorrow's Friday. That's correct. Folks, seriously, your stations need disassembled, cleaned up, put back the way they were. I don't see a single station that's acceptable right now. You guys don't get to go until the station looks like it did when you got there. That looks good. Everything neatly hung up on those corners like it was when you got there. The rulers lined up neatly on the table. No knots in the string. Please get them cleaned up. No, you won't probably be able to. I'm sure there's probably many, many things down the drain.
I will.
You probably wouldn't want your pencil back after it'd been down the drain anyway. It's kind of nasty.
My diamond. I think you went all the way down there. It's not in there no more.
Now there's a drain trap, so it can't go fast.
Well, what if we took off that seat part and like...
Well, we could. You just need a screwdriver and you need some pipe tape for when you put it back so that it seals again. And we could rescue her mangy old pencil. You need it desperately? Yes. Hey folks, let's stand up and get your chairs pushed under, please. just push it under. But you don't get to go till anybody else goes. Okay, Alex? Punch and Munch tomorrow, not Punch and Munch and movie, just Punch and Munch. You do have a quiz tomorrow. I want to look over some of the stuff we've talked about this week, like work and machines. Anything except for gum, corn nuts, sunflower seeds, and chips. Anything else is fair game. All right, I need Marcos, Mark, Ivan, and Asia. They owe me 2 minutes. The rest of you may go. Marcos, you owe me 15 minutes at lunch. Tomorrow. Expect to see you then. You weren't in your seat when the bell rang.